Okay, we have to find the equation of the normal line to the graph of this function at this particular x value 1. Okay, first off, we have the function who is x times the natural log of x. The derivative of this function will require the product rule, treating the x as the first function and the log x as the second function. Executing the product rule, we take the derivative of the first, 1, times the second, and then after that, we rearrange it and do it the other way. And so we leave the first alone, and we take the derivative of the second. Well, log x's derivative is 1 over x. So we've executed the product rule. Now what? We need to simplify. The first part is just a natural log of x, and the second term, these x's cancel. You just get plus a 1. And this is your derivative. This is your derivative at any value of x. And what we're going to look for is the derivative evaluated at 1. You see, the derivative at 1 is the slope of the tangent line. And the connection between the tangent line and the normal line is that the normal line is perpendicular to the tangent line. What does that mean for us? Well, perpendicular lines have opposite reciprocal slopes. And so, if we know the slope of the tangent line, we can take its opposite reciprocal to get the slope of the normal line. So we take the natural log of 1 and we add on 1. Turns out that that's going to be a 1 because the natural log of 1 is 0. Alright, that is your tangent line slope. So, your normal line slope would be the opposite of that, and it's reciprocal, but, 1's reciprocal is just 1. Okay, great. And they want us to find the equation of the line. Whenever you're asked to find the equation of a line, you're going to need its slope, and we're going to need a point that's on the line. We're interested in the point where x is equal to 1. We just don't know the y value. Go back to the function, plug a 1 into it, and we get 1 times the natural log of 1, which is 0. And so we have a y value of 0. So we go with y minus y1 is m times x minus x1, point slope formula. And that gives us y minus 0 is negative 1 times x minus 1. Or just y is negative x plus 1. That is the equation of the normal line. Okay, that ends that question. Let's take a look at another question. We have a function f of x, and it's equal to negative x times the tangent of x. And we are asked to find the derivative at pi. And so once again, first function, second function, execute the product rule. Take the derivative of the first and multiply that by the second. Put a plus sign, leave the first alone, and multiply that by the derivative of the second. Negative x's derivative, negative 1. Don't touch the second, tan x. Don't touch the first, negative x. And then tan x's derivative is secant squared of x. There's your derivative. We could simplify, but not much really to simplify. Let me just write it without all the little squigglies in there. We have negative tan x minus x times the secant of x. Let me put parentheses and square that way. Our job, evaluate this at pi. So we have to take the tangent of pi, subtract pi times the secant of pi, and we have to square that. So tan pi, secant pi. What is the tangent of pi? So pi is here on the unit circle, and on the unit circle, that particular point has coordinates -1, 0. The cosine of pi is -1. The sine of pi is 0. The tangent of pi is the sine of pi divided by the cosine of pi, and so we get 0. This part is a 0. The secant of pi is 1 over the cosine of pi, and we just showed that the cosine of pi is -1. Turns out that the secant is also -1. But that -1 gets squared. And so we end up with -pi times 1, or -pi, as our answer to the derivative at pi. Okay, all right, great.